All right, here we go. This is going to be a note page on mixture. So I'm going to explain to you how we do these three types of problems. They are very similar as we go through our example problems, but we're going to try to come up with one equation here. So go ahead and make sure we read this problem here and notice that we have cashews that we are hoping for. And we know as we read through the problem, there's my great visual of the can of cashews here, that we also have peanuts. So we have another container of peanuts. So we're going to take these cashews and we're going to take these peanuts and we're going to put them into a mixture. So that is the big idea of the problem, is that we take cashews plus the peanuts and it equals the mixture. Okay, so going through this problem now, we have obviously more information in it. And we can see here that the cashews are $6, not $6 for the jar, but $6 per pound. And the peanuts are $3 per pound as well. So when we put these together, the cashews are more expensive, the peanuts are less expensive. So when we make the mixture, it should make sense that the mixture is somewhere in between those two values. In this case, $4 per pound. All right, so that's very important information to understand. There's probably going to be more peanuts in this mixture when we're done here because the price is closer to the peanuts. All right, big thing now is we have 15 pounds in the mixture. Notice where I'm putting that in the mixture, 15 pounds. Well, that means we just don't know how many cashews there are. But just like our other problems and our simple interest, if we start with 15 and we take away x, we have 15 minus x left over. All right, so I'm going to put this in parentheses here, and that will help us get to our equation off to the side here. So the visual there is obviously not necessary, but it helps you set up that equation. So hopefully that'll help, and do that if you need to. So we got $6 per pound, and that's X pounds. So when we write the equation, it's going to be the product, multiplication of those two. Then we add to that the peanut value, which is $3 times however many pounds we have, which is 15 minus X. Do not forget your parentheses here. And then we set it equal to the price of the mixture times the pounds. No variables needed over here. We know how much that is. All right, so now all it is algebraic work. So at this point, we are going to take our equation and we're going to solve for x. No nasty decimals, which is good. So 6x plus 45 minus that 3x is equal to 60. Combine like terms. Do not add to both sides. They're on the same side. So combine those together and get 3x plus the 45 is equal to the 60. Take away that 45 from both sides, and we are well on our way here to finding out that our x value is going to be 5. All right, so I got x equals 5. Don't forget, we wrote x on our paper somewhere, and the first place we wrote x on our paper was over there by the cashews. So if you look at that, we know that the cashews will be 5 pounds, or the amount of cashews will be the 5 pounds. And then what's left over? 15 minus 5, or 10 pounds for the peanuts. So you just think about it at the end of the problem. Alrighty, so that's how we do that. You can plug them back in always to see if you are correct. On this one, this is gross. We're going to make a cranberry apple juice mixture. I don't know why anybody would want that, but that's what we're going to do. We got apple juice with 50% juice, and then cranberry juice, which is 25% juice. So what you will see right here is you will see something very similar as far as a mix. So we're going to put some apple juice, put some cranberry juice in, and we're going to get a mixture. All right, adding those percentages in, we have a 50%, and then we have a 25%. When you have percent juice, it does not add up to 75% juice. That's not how percentages work. It's actually going to be diluted. The apple juice will be diluted. The cranberry might go up a little bit, but the mixture itself will have 30% as explained in the problem. Okay, just like the other one, we have 5 liters. We start with the mix. We don't know how much apple juice, but you guessed it, 5 minus x is the cranberry juice there. Okay, so now once again, we do product plus product equals product for these mixture problems. So product plus product equals product. But we got to use the correct decimals instead of the percentages when we do this one. So we got 0.5 times the x plus 0.25 times however much we have, which is 5 minus x in parentheses here. Oops, I wrote 25. Why did I do that? Don't know, because I'm human. All right, so it's supposed to be 5 minus x. And then that equals 0.3 times 5. 0.30 is the exact same thing as 0.3, whatever you want to do. Okay, so now we are at our equation with one variable, and we can solve. So 1/4 of 5. That's not showing up real clearly, but basically we're just showing you that you can. There is nothing wrong with you using your calculator if you need to. So 0.25 times 5 is going to give us $1.25 minus 0.25x equals 0.3 times 5. There it is, 1.5. 3 times 5 is 15. One decimal place, 1.5. All right, again, just combining like terms here. We got 0.5x. We take away 0.25x, and we're going to get a positive 0.25x plus the 1.25. And I don't really need to narrate over this. You can see exactly what's happening here. We are algebraically solving for the x value. So divide, and we get x equals 1 heck of an answer, where x equals 1. Now don't forget, x had to stand for something, so that's actually the liters of apple juice, because that's where we first put x on our paper. And then 5 minus 1 would give you the 4 liters of cranberry juice. Again, I don't know why you would want to make that mixture, but that's what we did. Okay, one last one here on these mixture type problems coming up. Sorry, I am narrating over a video that I made already where the volume did not work, so I don't know what I was saying right there. Probably something I already said. All right, so on this one here, we got 40 coins. So in your pocket have 40 coins. There are only quarters and dimes. That's it. But they have a combined value of $8.20. Okay, so thinking this through, I don't think a visual necessarily of like just like the last problems helps as much on this one. It might confuse you a little bit. But the bottom line is we got one coin that's worth 25 cents and one that's worth 10 cents. All right, again, we have 40 coins in total. Like the total value of the money is $8.20, but the total coins we have is 40 coins. That's a big difference. We're not going to multiply those two values together. That doesn't make sense in this situation. Get it? Makes sense? Okay, anyways. All right, so what do we have? We got 40. Hopefully I'll get to it here. I'm obviously explaining the total value in this video here. But the bottom line is we know that there's 40 coins. We still do not know how many are quarters. But since there's only two types of coins, we do know that we have 40 minus however many are quarters right there. That will be how many dimes we have. So we have quarters that are worth 0.25 here. All right, so we're going to take the product of those 0.25 times however many we have, which is x, and we are going to add to that 0.1 or 0.10, both the same thing, and then we're going to multiply by however many of those we have, which is 40 minus x. Okay, now the big kicker is here, we are not taking 40 times 8.2. That is not what we're doing here. We already know the value. So when we go to the right side of this equation, we just set it equal to 8.2. If you don't do that, your numbers will come out really weird. All right, so there's your equation. Yeah, that's it. We basically just distribute through. We get ourselves the value here. I'll let you just watch. And I will say when we are done here, we have to, on this problem, come up with a whole number, okay, when we do this at the end, because we're talking about quarters and dimes. You can have a portion of like a My audio kicked out there. But what I was basically saying there is that you can have a portion of a liter, you can have a portion of like a pound of a mix or something. But you can't have a portion of a quarter. You can't have a portion of a dime. So when you do these problems, you are looking for whole numbers. If you don't get the whole number, then you did something wrong or the problem's faulty. But probably you did something wrong there. All right, so when we finish this and solve, we're going to get 0.15x equals 4.2. And then just divide both sides here by the 0.15. And then we're going to get x equal to, I believe, comes out to 28 when we do this one. Boom. It's like I've done this problem before. All right, so x is 28. Remember that stood for the quarters. You always go back to the beginning and you're like, oh, 28 quarters, which is going to leave us with 12 dimes. Looks like it might be off the picture a little bit, but 40 minus 28 gives me those 12 dimes. And then if you know what their value is, you'll see that it does come out to, checking our work, you can check them and see that it comes out to $8.20. And it works.